right-angled triangle trigonometry. This is familiar to us from previous years. We know that if we have a right-angled triangle, we can use some trigonometry to find unknown side lengths and unknown angles. So just a reminder, here we have a triangle and we've labelled it with conventions angle A, B and C. And we know that if this is angle A, this side length opposite it can be labelled as length A. Notice that it's a lowercase a. If we have angle B here, then our side length here is lowercase b, and then for C we have lowercase c for the side length. And we know our three trig ratios, so sine of C, so sine of this angle is opposite over hypotenuse, which is going to be C over A. Or if I wanted to do cos of C, so cos of this angle, it's adjacent over hypotenuse, which is B over A. And finally tan of C, which is opposite over adjacent, which is C over B. So sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. When we're working through these, you need to be careful and make sure that your calculator is set in degrees, not in radians. So just take a moment and quickly copy that into your exercise books. Since year 8 or 9, or even maybe 7, we have used area equals half base times height to find, if we know the perpendicular height, to find the area of any triangle. Now, what if we don't know what the perpendicular height and base lengths are in a particular triangle? Are we able to still find the area? Well, the answer to that question is yes. So let's come over to my page, and this is chapter 6 of our Hazy textbook. So here we have a non-right angled triangle, triangle ABC, and I've split this non-right angled triangle into two right angled triangles, and you can see at the point where it's been split I've labelled that point D. So let's have a look. What are the different side lengths? Since that's A, that length across there is A. Since this is B, that length will be B. And since this is angle C, that length there will be C. And now I know that this length here is my perpendicular height. So remember, we know that for any triangle we can find the area by multiplying it half times base times height. Now let's consider just triangle ADC. So we're considering ADC. Now in triangle ADC, if I was to consider this angle here, which is angle C, I know that sine C is equal to opposite over hypotenuse, which is h over b. So opposite is h over the hypotenuse of this triangle, which is b. Now, if I rearrange this equation such that h is the subject of the equation, so h is equal to b times sine theta, then if I substitute these values into the area of the triangle, now look at my large triangle here. Do I know what the base is? Yes, it's A, and I've written the perpendicular height in terms of this side length and this angle. So I can substitute this value in for the height. So if I substitute those in, what do I get? I see that area of this large triangle is equal to half times A, so length A, times length B, times sine of the angle C. So you can see here that I can find the area of this triangle without knowing its perpendicular height. This only depends on side lengths A, B, and angle C. So if I know two side lengths and the included angle, I can find the area of a non-right angled triangle. Now, just also note that if I know angle A, then it means that the side lengths that I need are B and C, And if I was to have angle B, then the side lengths are the two side lengths that enclose angle B, which are A and C. So if I knew angle A, then the two side lengths that I need are B and C. And if I knew angle B, the two side lengths that I would need are A and C. So we've just made note that this can only be used if angle C is the angle between A and B. Okay, so we need the included angle, which is included in between those two side lengths. So let's have a go at an example and we'll apply this rule. So take a moment to quickly copy this down. We have triangle ABC and we've got two side lengths and an included angle, and we're asked to find the area of this triangle. So we know that the area is equal to half. Now remember we have angle B, so that means that our enclosed sides are A and C, so half AC sine B, which is equal to a half times 11 times 15 times sine of 28, and substituting that into our calculator. Again, make sure that your calculator is set in degrees. We find that this is equal to approximately 38.7 centimeters squared. So, using this, I'd now like you to have a go at working through exercise 6A, which is on page 148 of the text. I've scanned this text onto Sector, so it's available for you, and you're going to be doing questions 1 through to 4.